I hope that from our examples you learned that delegating handlers can be really powerful and can solve a lot of potential issues when calling an API. A good example of another useful handler would be an authentication delegating handler when you're working with access tokens. Such a handler could be responsible for reading the token from wherever you stored it and potentially refreshing it when needed. Caching is also a typical thing to handle via a delegating handler. The handler is responsible for checking whether the response can be served up from a local cache or that it has to effectively communicate with the API to get a response. Another sample is one that Maarten Baljouw recently published, an ASTS handler. HTTP Strict Transport Security is a web security policy mechanism that helps to protect websites against protocol downgrade attacks and cookie hijacking. It allows websites to declare that web browsers or other complying user agents should interact with it only using secure HTTPS connections and never via HTTP. What Maarten did was write a handler that supports this at the level of HTTP client, thus ensuring safer requests. HTTP client now takes that policy in mind if the API forces it. You can find the code on his GitHub. And there's even more, but for that we're going to look into Polly. So we implemented a few handlers, but they can probably use some additional error handling, some more configurable options, and so on. Thing is, for most scenarios having to do with using a reliable way to call an API, there's a better option: Polly. Polly is a .NET resilience and transient fault handling library that allows developers to express policies such as retry, circuit breaker, timeout, bulkhead isolation, and fallback in a fluent and thread-safe manner. It has quickly become the de facto standard way of improving calls with HTTP client, extensively using policies and related handlers like we just wrote. So, a course on integrating with an API, like this one, isn't complete without talking about Polly. But rather than going into the details of that here, I'd like to suggest having a look at fellow author Brian Hogan's course, titled Fault-Tolerant Web Service Requests with Polly. It's an in-depth look at Polly, so check it out if you're interested. And with that, it's time for the module summary. In this module, we learned how to work with delegating handlers. These allow us to create a pipeline through which requests and responses flow. Each handler can decide not to pass on the request to the next one. Such a delegating handler should derive from the delegating handler abstract class, and by overriding the sendAsync method, we can check out or manipulate the request and response, and thus manipulate how they flow through the pipeline. We looked into this by implementing two samples, one to retry failed requests and another one to gracefully handle timeouts. But there's more use cases for handlers like caching, authentication, and HSTS support. Lastly, if you're looking for a proven library with .NET Core support to improve HTTP client integration with an API, Polly is the de facto standard today. In the last module, we'll check out one final use case for delegating handlers: unit testing. Custom handlers can be useful for unit testing the parts of your client app that integrates with an API. In this module, we'll learn how. I'm Kevin, and I'll guide you through it. We'll start by learning about use cases where it makes sense to implement HTTP client in such a way that it can be used in unit tests. After that, we'll learn how to do that by writing a custom handler and creating an actual unit test. We'll end up with learning how to use a mocking framework to create mocks of handlers. Let's dive in. So, what do I mean when I'm talking about unit testing with HTTP client? Well, imagine you want to test a part of your application that uses HTTP client to call an API. This can become cumbersome, as you don't want to actually call the API. It's not an integration test. Moreover, constantly calling a service that's cloud hosted can cost you money. You just want to test one specific piece of functionality that happens to rely on data being returned from an HTTP client call. Or you might want to test if your error handling is okay. For example, when a call comes back from the API with a 401 unauthorized status code, does the method throw an unauthorized exception so the rest of your application can act on that? One possible approach is trying to mock out HTTP client altogether, but that won't work. For one, HTTP client doesn't implement an interface we can mock. We can, however, write a custom handler to stop communication with the API and return the response we require for our test. For our use case, we don't want to communicate with the API, but we do want to get back 401 unauthorized response. Let's check that out. In this demo, we'll implement a custom handler to allow unit testing with HTTP client. So let's add a new class. We'll name it Return 401 Unauthorized Response Handler. This time, we don't need to pass the request on to a potential next handler, so we don't need this class to derive from delegating handler. Instead, we can derive from HTTP message handler directly. That's defined in system.net.http. It's an abstract base class, so let's implement it. We see one method, sendAsync. Nothing new here. It's the same method we had to implement for our delegating handler. Our scenario is, don't communicate with the API, but return a 401 unauthorized response. So we generate a new HTTP response message with status code unauthorized. Then we return that from the sendAsync method using task.fromResult because the return type is a task. Let's save this. Before we can write a unit test, we need to have a class and method we want to test. So let's add such a class. We'll name it Testable Class with API Access. We are going to construct this one a bit differently from what we've done up until now, because we need it to be more in line with how you'd write a class you want to make testable in a real-life situation. Notably, the dependency should be injectable. So we add a constructor that accepts an HTTP client instance. And let's add the using statement to system.net.http so we have access to HTTP client. It's in our unit test that will provide this dependency, which will use our newly created return 401 unauthorized response handler. So far, so good. And then we need a method to test. As mentioned, we want to test that the method executes correctly when we receive a 401 unauthorized response. That does sound familiar, because when we learned about dealing with faults and errors, we already wrote code that looked at the status code of the response to see if it returned a 404 not found or, indeed, a 401 unauthorized. So this will look very familiar. Let's add a new method and let's name it getMovie. It's an async method and it returns a task of movie. Task is defined in system.threading.task, so let's add a using statement to that. Movie is defined in our models namespace. And cancellation token in system.threading. The implementation, as mentioned, will look very familiar. Let me paste that in. And let's add the necessary using statements. So we try and get a movie. If all works out, we return that movie. But if it doesn't work out, we check the status code. Typically, you want to trigger a login flow when unauthorized access is detected. Let's say we want to throw an unauthorized API access exception when that happens. So another part of the application can respond to that and trigger the flow. That type of exception doesn't exist yet, so we'll have to create it. When we choose to generate a class, Visual Studio is smart enough to generate an exception for us when it notices the exception suffix. So let's press enter. And if we look at what's generated, this is indeed a custom exception. The only thing we want to change here is the internal modifier. We want the exception to be public as we're going to test for it in a unit test project. And that's it for the method we're going to test. Now let's create a unit test for this in the next demo. In this demo, we'll write an actual unit test. Let's add a new solution folder, 03 unit tests. And let's add a new project to that folder. We want to create a unit test project, and for this demo, I'm going to choose an XUnit test project, as that's the one I'm most familiar with. However, the principles we'll learn in this demo can be applied to other unit test frameworks as well. So if you prefer to use another one, that's possible. Choose the one you're comfortable with. Now let's name this project movies.test. There we go. It automatically created a new class, UnitTest1, but that's not really a descriptive name. We're going to test our testable class with API access, so let's name the unit test class testable class with API access unit tests. When I change the file name, it prompts me to change the class name as well, so let's click yes, and there we go. That testable class with API access is defined in our movies.client. So let's add a reference to that project. There we go. What we want to test is that if we get back a 401 unauthorized when getting a movie, an unauthorized API access exception must be thrown. So let's name our test getMovie on 401 response must throw unauthorized API access exception. Then we want to instantiate the dependency for our testable class with API access, and that's an HTTP client. So we construct a new client, which is defined in system.net.http, and we pass through our return 401 unauthorized response handler as the primary handler. That one is defined in movies.client. So let's add a using statement by pressing enter. This client is what we want to pass through to our testable class with API access. So we instantiate a new class and pass it through via the constructor. We've now got a testable class with API access object on which we call getMovie. GetMovie expects a cancellation token. So let's make sure we have one. We create a new cancellation token source, which is defined in system.threading, so let's add a using statement. And from that cancellation token source, we can get the token. Now let's think about what we want to assert. We want to assert that the method call into getMovie throws an unauthorized API access exception. As it's an async method, we use assert.throwsAsync for that. As the action parameter, we pass through the call into getMovie. Alright, let's give this a try. These tests can be run from Test Explorer. So let's open that. If you ever wonder where to find a window or setting in Visual Studio, the search box on the top right is your friend. I tend to use it a lot. Alright, our test was discovered. Let's run this. And there we go. Our test executed successfully. Important to notice is that we did not have to start our client application, nor did we have to start our API. The API does not need to be up and running, as we won't actually communicate with it. So this works, and this avoids communication with the API. Yet, having to write custom handlers for each and every API call so it returns the expected response for both successful and failed responses, well, that's a lot of work. So is diversifying between resource URIs inside of the handler to return responses, if you would choose to go that route. Luckily, there's another option, using a mocking framework. Let's check that out in the next demo.